Welcome to class again. Time for us to reflect a little bit on some of the things we've learned, particularly from Pa and Ma Kettle and from the infamous horse problem. I have also posted a video under the horse problem discussion. Now that you've had a chance to think through it, if you haven't seen this already, you may want to go back and take a look. I just don't want anyone to have any questions as to what the correct answer is and why that answer is correct. So if you've not had a chance to do so, please go back and watch that video after our session today and before the asynchronous class of next week. That way we'll all be starting on the same page. First of all, I can't tell you how much fun it was on this side of the class to be listening and reading through your discussions on the horse problem. I've used this problem for probably 30 years now and have always been impressed by the degree of discussion that it can get started. I gave everyone pretty much a standard set of feedback, in particular that this problem does a good job in terms of discussing about the difference between the arithmetic, which is very straightforward. Basically, you add 10 and you subtract 10, and the mathematics, which has to do with when does the transaction start and when does the transaction stop. The other thing that the horse problem does, though, is that it reinforces a very powerful teaching technique that I want to explicitly share with you. It is, if in doubt, just act it out. And we forget how to do this sometimes. As adults, we are so used to just pushing symbols back and forth and using calculators and spreadsheets, and sometimes we even forget what the numbers are that we're working on, as long as we come up with an answer. Well, in this case, you could have the best calculator and supercomputer in the world, and if you didn't understand the mathematics in terms of where the problem started and where it stopped, it's not going to help you. You see, the arithmetic's quite easy, isn't it? Just add 10, subtract 10, add 10, subtract 10, or some multiple of 10. There's a lot of different ways we can approach this problem. In any case, the arithmetic, because it is so easy, really highlights the fact that when we don't get the correct answer, there's more to it than just process. And processing is what most people think of when they think of mathematics. Unfortunately, processing is the thing that is most easily replaced by a calculator. And in fact, if you don't have a calculator for this class, let me encourage you to get one and make a habit out of bringing it with you. See, I have a calculator that I use quite a bit. You probably have one a little bit different than this one. This is one that I use because it has a lot of graphic capabilities that we'll never use in this class. But let me encourage you to bring your calculator. And if you think you don't have a calculator, let me tell you that you probably do. It's on your cell phone. Just get used to bringing it, because we're going to assume that of the two things to teach, getting a correct answer using a calculator and really understanding the math, in other words, the arithmetic and the mathematics, the arithmetic is going to be easier to teach. And that certainly is true. Pa and Ma Kettle, as we mentioned, are not stupid. They're actually quite intelligent people. They just have their own ways of dealing with things. And in reading your discussion posts as you put things forward, I was really impressed with how many of you noticed what is probably the biggest gap in their understanding. That is that Pa and Ma Kettle have no notion of place value and number whatsoever. If they really understood number and place value, they would certainly understand how to act upon number and place value. And this brings up our first little diversion here of many. That is that when we teach mathematics, if we do not teach number and numeracy, that means that number is going to be poorly understood. And if number is poorly understood, operations upon number, and by operations, I'm not referring to Piagetian operations at this point, I'm referring to these standard mathematical operations of comparison, addition, subtraction, multiplication, and division. If number is not understood, how can we act upon something we don't understand? Well, very poorly, as Pa and Ma showed. If we understand, however, then we can act upon number, and the acting upon number is indeed what gives rise to the operations. Now, if we take this to the next logical step, let's assume that we really understand the operations. We really understand addition, subtraction, multiplication, and division. We get it, all right? Well, when we start acting upon the operations, what do we get? We get algebra. And that really is what algebra is. It's a formalized way of acting upon operations rather than acting upon the number primitives that the operations are built upon. And of course, as you might guess, it doesn't stop there either. What happens when we act upon the operations in algebra? Well, what is an operation in algebra? Well, it's a function. When you start acting upon a function, what do you get? Well, you get the calculus and differential equations. So we start seeing this nesting of ideas, and what lives at the very base? Well, at the very base, we have number and numeracy. And this is why we spend so much time at the beginning of the class really trying to develop these numbers and what they mean and what they look like and what relative powers of 10 do to us, and simple ways of making sense, whether it's through song or through game, so that we have a notion that when we see a 10, it's not just something that's one to the left of a 1. That's what a lot of first graders say. They say, what's the difference between a 1 and a 10? Well, they say the 1's over here and the 10 is over here. Well, we need to be better than that. We need to know that every time we make a shift, we go up by 10 of the preceding units. So a 10 is 10 times bigger than a 1. 100 is 10 times bigger than a 10, and so on. And once these notions are in place, then we can certainly act upon number effectively, and we can certainly take care of Pa and Ma Kettle. Well, this was a lot of talking on my part. I think it's time that you start doing a little bit of talking on your part as well. I'm going to open up the discussion boards, and as you go into the discussion boards, the first thing I'd like you to do is to review with one another your responses to Pa and Ma Kettle. I have to commend you, by the way, for the number of people who recognize the role of manipulatives. We sort of primed the pump a little bit on that for you. But manipulatives really are a powerful way of acting things out. And remember, if in doubt, act it out. And we certainly can do that with Pa and Ma Kettle, can't we? So discuss with one another two things. First, your ideas on teaching Pa and Ma Kettle. And then secondly, share what your models looked like in terms of base 10. I'd like for us to regroup after our discussion time, and we're going to kind of classify these base 10 models by type and use that as a way of reinforcing what makes a good manipulative.